All right, section 7.4 is conditional probability. This is where the sample space changes depending upon the wording of the problem. And the sample space is what you divide by. So here's the code for this. Equation number, or the first thing I'm going to tell you is the probability of E with a line like this, and then F. Okay, so it's not the probability E or the probability of F or the probability of E and F. It's written, it's the probability of E, so E is first, given F. So the line, that's that line right there, that means given. So it's probability of E given F. There's a formula for it. The probability of E given F is the probability of E intersect F. That's the overlap between the two circles, divided by the probability of F. And so when this F appears here, you're dividing by the probability of F there. Now this could be switched in order. So you could have the probability of F given E, and E and F are just letters of the alphabet we're using. You could use A and B or whatever. So I believe E is like event, so probability of the event, and then F is the next letter in the alphabet. Like F stands for function most of the time, so E stands for event. So the probability of this event given this event, right? And then if it's this way, the E is second, so it goes on the bottom. So probability of E intersect F and probability of F intersect E, those are the same thing. So you could switch the order of those, it doesn't matter. So you just leave it probability of E intersect F is by the probability of E. So when you do the formula, just remember that you're dividing by the probability of F, and then when it looks this way, you're dividing by the probability of E. Now, algebraically, sometimes this is handy. You can multiply the probability over. So I'm just going to do the first one here. So sometimes you can write it this way. So multiply this over using algebra. So the probability of F times the probability of E intersect F is equal to the probability of E intersect F. All right, so conditional probability is important, and it because it sets up the next section, which is section 7.5. And I will explain section 7.5 to you in person on Thursday. So tomorrow, Wednesday, you will do have a work day, a catch-up day, or a mustard day, whichever you want to call it. All right, let's go through some problems here. I don't have examples. I just said, hey, do this assignment. We'll do a few of them together so you can understand what's going on here. All right, so we have a French professor, and he's doing translations here, and we're trying to get the translations correct. So it says in section 1, 24 students, 7 get the passage translated correctly. So 7 out of 24. In section 2, 21 students, 9 get it correct. Okay, so in section 2. All right, A. One paper is selected at random. What is the probability that it is a correct translation? So there are 16 total. So we're looking at the total, like all the papers together. So there's 16 total, and the sample space is the addition of those two together. So that'd be 45. B. One of the papers is selected and is known to be from section 1. What's the probability that's a correct translation? Well, I already wrote that down. So see, it's not all the papers. What's the probability given section 1? So we exclude those. So it's given section 1. So this is the conditional probability. That's 7 out of 24. That's easy. C. Now we have the switched around the opposite way. What's the probability the paper is selected is known to be correct? So now it's given correct. What is the probability that it's from section 2? So it's correct, so that means only 16 are correct. So the sample space just switched from 45 to 24 to 16 because it's given correct. So it's out of 16. And we want it to be from section 2. That was 9 of them. So it'd be 9 over 16. All right, let me move this keyboard out of the way. All right, so that's question 3, the whole thing, and you can see how the sample space changed based on whether it was we knew it was from a certain section or we knew that it was correct. So that would be like switching these around each direction, right? And I didn't use the formula because I didn't really need to, because I'm just basically dividing the numbers. All right, let's look at number 12 next. So I have the two formulas here. All right, and it asks us to find, I'm doing 12, which is not part of the assignment, so this is like an example, the probability of E given F. So the probability of E given F is the intersection probability, which is 1/5, and divided by the F matches there, so probability of F is 3/5. So 1/5 divided by 3/5 is 1/3. And if you don't remember that, keep, I need to change color, keep the fraction, switch the fraction, change the sign, or keep, switch, flip, or whatever you want to call it, right? So that would flip over and that would cancel out, so it'd be 1/3. Or you can type it in the calculator. The second one is, I'll call it B, probability of F given E would be the same thing on the top. It'd be 1/5, but now I'm dividing by the probability of E. Probability of E is 4/5. So we keep, switch, flip. So this flips up and becomes 5/4, and then those cancel out, and we get 1/4 equals 1/4. So they're different answers. They could, there's probably situations where they could be the same, but they are definitely different. All right. Then I wanted to talk about 17. The 17's down here. So these are the ones I've done this problem in Algebra 2 before, in Honors Algebra 2, and did a little probability thing. And people, you have to pay attention. Sometimes you can read across, and sometimes you read up and down. So if it says something like, hey, look at the males, right, given male, then you're picking out of these numbers here. If it says given female, then you're going across this way. If it says given regular coffee, then you're reading it this way. You're picking male and female out of given coffee. So let's focus on D and E. So we have all those numbers right here. It says prefers decaffeinated coffee. So and it says the student being selected from the male students. So we're given male student, right? So we're given male student, and they prefer, let's see, did I do that backwards? Oh, no, I didn't do it backwards. I'm okay. Yeah. I'm getting mixed up here. Okay, let me read this again. Prefers decaffeinated coffee. The student being selected from the male students. Oh, okay. So out of the male students, I had a backwards moment myself there for a second. So it's given male. So we're looking out of 260 because we're reading it this way. And then there's 46, right, that prefer decaffeinated coffee. Okay. So you're reading that left and right because we know that it's being selected from the male students. Okay. Now is male. Oh, now we want male, but is given that the student prefers decaffeinated coffee. So we're reading it this way, right? Reading it this way, and it's still 46 males, but it's out of a different number. So the sample space changed from 260 to 115. So this one is 46 out of 115. All right, so that's what's going on with that one. Okay. Now I'd like to skip to number 29. 29 is 29A. It says 15 cards are numbered 1 to 15. 2 cards are drawn with replacements. That means you're putting it right back in. So find the probability that it is that both are less than 5. So you're putting it right back in. So this would be 4 out of 15. So there's 4 of them that are less than 5. And then you're just doing the same thing again. So you'd multiply by 4 out of 15 again. So it's just 4 out of 15 times 4 out of 15. So the second one is a little bit different. You have to think about that and figure out what the answer is. Okay, 37 is where I'd like to go next. 37. Okay, so it says we have a fourth grade class. We have boys and girls in the class. She selects randomly 2 students to return books to the library. Find the probability that they're 2 girls. All right, so it's just 2 girls. There's no order to it. These down here say order is important, order is not important. So 2 girls. So that's C, 20, comma 2, because there's 20 people in the class. And then we're picking 2 girls, C, 9, comma 2. There it is. And that would be part A. Figure out that answer. You can get the fraction. You can check it with the answers that I gave you. B, boy and girl in that order. So it has to be a boy. So it'd be 11. So order matters. It'd be 11 out of 20 times, and it has to be a girl. So it'd be 9 out of 19. So it's 11 out of 20 times 9 out of 19. Right? And so you multiply those together, and you could check your answer with that. Now, order doesn't matter. So it could be a boy picked and then a girl, or a girl picked and then a boy. Order doesn't matter. So it's going to be 11 out of 20 times 9 out of 19. Or you could pull a girl out first, 9 out of 20 times 11 out of 19. Well, notice these are basically the same numbers multiplied together. So what you could do is you could just do 11 out of 20 and then 9 out of 19 and then multiply that answer by 2 because it's really just doubled. All right. So conditional probability changes the sample space. And that's really seen right here, right, on this coffee example. One sample space would be 900 or 497 because that's all the people in the group, right? That's all the people in the whole survey or whatever. And then if you're looking at it left and right, you're either picking out a female or a male. If you're looking at it up and down the columns, you're picking out a 41, 341, 115. Right? Or you could pick out of the total. So left and right versus the columns up and down, the rows versus columns changes the sample space and makes it different conditions. Now, conditional probability is a stepping stone into the next section, which is independent events, which is different than mutually exclusive. So we'll have to sort that all out when I get back.